Hello, we are Omdena Algeria Chapter and we are presenting our last project, Green Algeria Project, Building an Intelligent Control System for Greenhouses. Climate change and growing urban population are among the problems that are besting the agricultural production in Algeria and in many regions in the world, where improving food security can be only achieved by enhancing local production of important products. Our objective during this project was to develop modern and sustainable protected greenhouse cultivation in Algeria. This will help farmers during their farming routines using advancements in artificial intelligence and machine learning by means of ready and easy-to-use tools. During 6 weeks, more than 50 collaborators were working together following this timeline. We started our journey by doing a research and problem study task. This task was taking about 1 week and during which we were analyzing more than 100 research papers and also available data sets related to greenhouses cultivation. After this step, we noticed that our topic cannot be tackled directly as it is because it contains several sides and problems. For that, we decided to divide ourselves into 3 main teams. Each team work on a kind of a problem. Those problems are diseases and anomaly detection of plants inside the greenhouse climate conditions, and also the water and irrigation management. All those problems are in fact affecting the productivity, the quality, and the sustainability inside the greenhouse. So each team was working on the exploratory data analysis with data exploration, some methods of interpolation to discover patterns and spot anomalies. And then we proceed with the pre-processing step for data cleansing, sampling, wrangling, and also splitting to be prepared for the model building. After that, we proceed. After doing our model building for each team, we proceed with the deployment of our systems. So each team was working on his web application using the Streamlit versions, and then we merged all the 3 works into one web application to be served to the farmer. So after that, we worked on disseminating our works during a conference in Abu Dhabi, and also working on a publishable paper. So just to give you a kind of a showcase or a demo for our project, let me just access to the application, the web application. So here you can find definitions about our project, our chapter, and also our team, and so on. You can then proceed with the indoor climate factors project. So here you can see that you can upload a file by clicking on browse files, and then here I am uploading this file. And when click on diagnose, I will have predictions. So just to be clear, this can predict 6 factors inside the greenhouse for the next 5 minutes. So it includes indoor temperature, indoor humidity, indoor lighting, indoor CO2, soil temperature, and soil moisture. So this prediction is a kind of giving the farmer insights on the best values to be set inside the greenhouse for the next 5 minutes to have the best quality and quantity of tomato. So this can be also done on other types of crops inside the greenhouse. You can also access to the second project, which is diseases and pest detection. So here, just let me try. So here you can also browse files and upload an image of your plants or leaves. Like here I am having a healthy leaf image. Just when you click on process, you can have the result. So waiting for the result to be uploaded. So here we can see the image, the processing of the image for prediction, then once the progress or the processing is completed, we can have the results. So it is said here that our crop leaf is healthy and predicted class is tomato healthy with probability of 96%. Let me just change the image and try an unhealthy leaf plant. So just one clicking on process, we will have the processing as well for prediction. And here we can see the result. So it is saying that our crop leaf is not healthy, and it can also detect or classify the anomaly. So it is saying that the predicted class is tomato leaf mold, which is a known anomaly with a probability of 97%. The third system, it is about recommendation system. So it is more about binary classification of whether our greenhouse or our plant need irrigation or it is already irrigated. So this can help us manage more responsibly and effectively water resources inside the greenhouse. So whenever it is not irrigated, we can irrigate with the appropriate amount of water, and whenever it is sufficient, we can stop irrigation and just close our sensors and so on. So just let me choose any kind of plants, and then here you can just say that it have 9 days. We can say that soil moisture is about 15. The current temperature is about 25. So I am just putting random values, but for sure the farmer can upload here or can put here the right values inside his greenhouse. Okay, so just let me say it is about 70%, and then when submit, this is saying that my crop is irrigated. So just let me say here it is 0. This is just an example. So you can try other values, and the farmer can have other results whenever he upload other values for his plants. So this nice work was presented by this nice team. So we learned during our journey a lot of things, especially on especially on the side of project management. So we learned that it is always a good practice to divide the main project into sub-projects regarding the nature of the problems, types of inputs and the desired outputs. This is why problem study and user needs investigation are important. Also, we learned that on the technical side, that available greenhouses data sets and environments and also resources are still limited. So this makes this kind of projects very challenging in one hand, but also very promising with more space for innovation in the other hand. On the project management side, we learned that in every machine learning project, the exploratory data analysis and pre-processing steps should take the biggest portion on the design timeline, because at the end, the quality is the most important goal. Also, diversity of skills, ideas, and visions make a positive impact on the project outcomes. We will have the help of a very talented team composed of students from VIT Bhopal, India, also from Ain University, Algeria, from Morocco, from Pakistan, and from Mexico. We had also the help of some machine learning engineers from the two universities from India and Algeria, in addition to nice inputs from people or collaborators from Tunisia and Jordan. We had also the pleasure to have with us some junior machine learning engineers to learn together how to build a real project for greenhouses in Algeria and worldwide. So a big thank you from me, the chapter lead, and shukran min al-Jazair. Thank you.